Chapter 8, Lesson 1 on page 218. Chapter 8 is all about solutions and solubility. As we learn about the different types of substances, mixtures, and how they're soluble, we're going to start with answering this question: what is a solution? Our objectives for today's lesson are on page 218. They say we will distinguish between substances and mixtures, describe two different types of mixtures, explain how solutions form, and describe different types of solutions. Let's get started. Substances. Water, salt water, and pulpy orange juice have some obvious differences. These differences can be explained by chemistry. Think about pure water. No matter what you do to it physically, freeze it, boil it, stir it, or strain it, it still is water. On the other hand, if you boil salt water, the water turns to gas and leaves the salt behind. If you strain pulpy orange juice, it loses the pulp. How does chemistry explain these differences? The answer has to do with the chemical compositions of these materials. Atoms and elements. Recall that atoms are the basic building blocks of matter. Each atom has unique chemical and physical properties which are determined by the number of protons it has. For example, all atoms that have 8 protons are oxygen atoms. A substance is matter that has the same fixed composition and properties. It can't be broken down into simpler parts by ordinary physical processes such as boiling or grinding or filtering. Only a chemical process can change a substance into one or new substances. Table 1 lists some examples of physical and chemical processes. So those physical processes are described there as boiling, changing pressure, cooling, sorting. Chemical processes, on the other hand, are burning, reacting with other chemicals, and reacting with light. So a substance can't be broken down into similar parts by a physical process. Only a chemical process can break those things down. An element is an example of a pure substance. It cannot be broken down into simpler substances. The number of protons in an element, like oxygen, are fixed. It cannot change unless the element changes. Compounds. Water is another example of a substance. It is always water even when you boil it or freeze it. Water, however, is not an element. It is an example of a compound, which is made of 2 or more elements that are chemically combined. Compounds also have fixed compositions. The ratio of the atoms in a compound is always the same. For example, when 2 hydrogen atoms combine with 1 oxygen atom, water is formed. All water, whether it's in form of ice, liquid, or steam, has same ratio of hydrogen atoms to oxygen atoms. Mixtures. Imagine drinking a glass of salt water. You would know right away that you weren't drinking pure water. Like salt water, many things are not substances. Salt water is a mixture of salt and water. Mixtures are combinations of substances that are not bonded together and can be separated by physical processes. For example, you can boil salt water to separate from the salt from the water. If you had a mixture of iron filings and sand, you could separate the iron filings from the sand with a magnet. Figure 1 shows how mixtures are being separated. Unlike compounds, mixtures do not always contain the same proportions of the substances that are composed of. Lemonade is a mixture that can have a strong taste or a weak taste, depending on the amount of water, lemon juice, or sugar that's added. It also can be sweet or sour, depending on how much sugar is added, but whether it is a strong, weak, or sweet or sour, it is still lemonade. Heterogeneous mixtures. It's easy to tell that some things are mixtures just by looking at them. A watermelon is a mixture of fruit seeds. The seeds are not evenly spaced throughout the whole melon. One bite you might not have any seeds in it, and in another bite you may have several seeds in it. A type of mixture where the substances are not mixed evenly is called a heterogeneous mixture. Different areas of heterogeneous mixtures have different compositions. Substances in a heterogeneous mixture are usually easily to tell apart, like the seeds and the fruit of watermelon. Other examples of heterogeneous mixtures include a bowl of cold cereal with milk and the mixture of pens, pencils, and books in your backpack. Here's an example of a heterogeneous mixture. Homogeneous mixtures. Your shampoo contains many ingredients, but you can't see them when you look at the shampoo. It's the same color and texture throughout. Shampoo is an example of a homogeneous mixture. A homogeneous mixture contains 2 or more substances that are evenly mixed on a molecular level, but are still not bonded together. Another name for a homogeneous mixture is a solution. The sugar and the water in a frozen pop, shown in figure 2, are solutions. The sugar is evenly distributed in the water, and you can't see the sugar. Here's another example of a homogeneous mixture. This paint would be the same paint all the way throughout. We'd call this a solution. Here's a pizza that has different ingredients such as the pepperoni. You get the little the greens on here, the onions, the cheese, the crust. Because it's got different pieces and they're not evenly mixed, we would call this a heterogeneous mixture. Water, pure water, is going to be in the form of a homogeneous mixture, or in this case, a pure substance because it's a compound of H2O. Kool-Aid, on another example, is a mixture. So here's a substance, here's a mixture. Substance, mixture. Even throughout, it is made of the different elements, hydrogen and oxygen. This has different ingredients that are mixed together. They're not bonded together, but they are mixed together. This is a homogeneous mixture because it's the same throughout. How solutions form on page 220. How do you make sugar or water for a hummingbird feeder? You might add sugar to water and heat the mixture until the sugar disappears. Sugar molecules would spread out until they were evenly spaced throughout the water, forming a solution. This is called dissolving. The substances that dissolve or seems to disappear is called the solute. The substance that does the dissolving is called the solvent. In the hummingbird feeder solution, the solute is the sugar and the solvent is the water. The substance that is present in the greatest quantity is the solvent. So the biggest of those items is the solvent. The thing that is being dissolved is the solute. Forming solids from solutions. Under certain conditions, a solute can come back out of its solution and form a solid. This process is called crystallization. Sometimes this occurs when the solution is cooled or when some of the solvent evaporates. Crystallization is the result of a physical change. When some solutions are mixed, a chemical reaction occurs, forming a solid. The solid is called a precipitate. A precipitate is the result of a chemical change. Precipitates probably have formed in your sink or shower because of chemical reactions. Minerals that are dissolved in the tap water react chemically with soap. The product of this reaction leaves the water as a precipitate called soap scum, shown in figure 3. Stalactites and stalagmites in caves are formed from solutions, as shown in figure 4. First, minerals dissolve in water as it flows through rocks at the top of the cave. This solution of the water and dissolved minerals drips from the ceiling of the cave. When drops of the solution evaporate from the roof of the cave and the minerals are left behind, they create the hanging rock formations called stalactites. You know they're stalactites because they got to hang on tight if they're hanging from the ceiling. When drops of the solution fall onto the floor of the cave and evaporate, they form a stalagmite. Very often, a stalactite develops downward while a stalagmite develops upward until the two meet. One continuous column of this mineral is formed. This process will be discussed later. Types of solutions. So far, you've learned about the types of solutions in which a solid solute dissolves in a liquid solvent. But solutions can be made up of different combinations of solids, liquids, and gases, as shown in figure 2. So we're going to look at the differences between what we'd say as a gaseous solution, a solid solution, and a liquid solution. Liquid solutions. You're probably most familiar with liquid solutions like the one shown in figure 5, in which the solvent is a liquid. A solute can be another liquid or a solid or even a gas. You've already learned about liquid-solid solutions such as sugar water and salt water when discussing solutions. The rate of the solvent usually determines the state of the solution. Here's another example of liquid gas solutions. Carbonated beverage are liquid gas solutions. So you open your can of soda and it goes ka-ch. That little noise is the gas that's been dissolved inside that liquid being able to be released because it's now not under pressure. Carbonated beverages are liquid gas solutions. Carbon dioxide is a gaseous solute, and the water is the liquid solvent. The carbon dioxide gas gives the beverage its fizz and some of its tartness. The beverage also might contain other solutes, such as the compounds that give it its flavor and color. Our reading check says, what are the solutes in a carbonated beverage? In this case, it's the carbonation itself. It's that gas that's inside of it that gives it that fizziness. If you've ever left your soda open, it probably has gone flat. That means a lot of that gas that was dissolved, the solvent that was dissolved in that solution, has now gotten out of the solution, and that's why you have that flat taste with that soda after a longer period of time. Liquid-liquid solutions. In a liquid-liquid solution, both the solvent and the solute are liquids. Vinegar, which you might use to make salad dressing, is a liquid-liquid solution made of 95% water and 5% acetic acid, the solute. So whatever's in greater composition, the greater amount is the solvent, the smaller amount is the solute, and that solute can be solid or liquid from what we've learned so far. That is liquid solutions. So they can be liquid gas or liquid-liquid, or a solid can dissolve inside of a liquid as well. Gaseous solutions. In gaseous solutions, a smaller amount of one gas is dissolved in a larger amount of another gas. This is called a gas-gas solution because both the solvent and solute are gases. The air that we breathe is a gaseous solution. Nitrogen makes up about 78% of the dry air and is the solvent. The other gases are the solutes. So solutions can be a combination of these solids, liquids, and gases. In a gas solution such as air, the largest amount is nitrogen. That would be the solvent. Again, smaller amounts are the solute. In this case, oxygen, what we need to survive, is the solute in that solution. But you didn't know this because we think about oxygen as being this most important thing for our breathing. It's actually nitrogen that is the greatest amount and percentage of the air that we breathe. About 78% is nitrogen, about 21% is oxygen, and then there's left about 1% for the different types of gases that might be floating around. Solid solutions. In solid solutions, the solvent is a solid. The solute, the smaller amount, can be a solid, liquid, or a gas. The most common solid solutions are solid-solid solutions, one in which the solvent and the solutes are solid. A solid-solid solution made from two or more metals is called an alloy. It's also possible to include elements that are not metals in alloys. For example, steel is an alloy that has carbon dissolved in iron. The carbon makes steel much stronger and yet more flexible than iron. Two alloys are shown in figure 6. So the final example is a solid-solid solution where you have different types of solids that are mixed together. When you have those different types of metals or solids mixed together, we call those an alloy. So here you have an example at the top where steel is just iron and carbon atoms, and brass, which is copper and zinc atoms. So you got two different types of metal that are put together. That's what makes it an alloy. Now that should finish our reading and our notes for this section. God's blessings. Make sure you read through the instructions to finish your reinforcement.